Hello everyone, this is Nilu Parvinashtiani from NOCO. Welcome to today's webinar, the Connected Fleet Challenge webinar number 3. This webinar is being sponsored by CAT Coalition in cooperation with the National Operations Center of Excellence, or NOCO. So if you don't know about NOCO already, we support resources to support the transportation system management and operations community. On the bottom left side of your screen right now, you see a pod called Useful Links. So from there, you can browse to our website, connect to us via our newsletter or on Twitter, and also you can view previous webinar recording, including previous webinars from this series, and also all NOCO case studies. So I would like to cover a few logistics before we start off with the webinar today. All the webinar attendees are on mute by default, but we would like to have you be engaged by using the question discussion pod that you see on your screen right now. So we dedicated some time at the end for question and answer, and we'll read each of your questions out loud one at a time, and our presenters will answer each question. This webinar is being recorded, and the recording along with the presentation slides will be available through the on-demand learning section of NOCO website. You can also directly download the PDF of the slides from the pod you see on the bottom that's called Files for Download. And you'll see this pod here at the beginning, and then later during Q&A we'll bring this up again. So that's kind of all I had with the logistics and the intro. And with that, I would like to hand it over to Jeremy Schroeder to start us off.
All right, thank you, Nilu. And welcome everyone, and thank you for joining us here on our third Connected Fleet Challenge webinar. My name is Jeremy Schrader with AP Creek, and I've been supporting these webinars and SPaT Challenge and Connected Fleet Challenge webinars all along, but today I'm standing in for Blaine Leonard, who usually leads us off in our welcome and introduction, and he was unfortunately not able to join us today. So again, thank you and welcome everyone for joining us. After my little introduction and update this morning on the Connected Fleet Challenge, we have 3 presenters today that we'll be hearing from. The first is Asfand Siddiqui of Caltrans, who will be talking to us about their deployment of onboard units, transit signal priority application, and experiences with tool testing and automated vehicles there in District 11. Following that, we'll be hearing from Rafal Ignatowicz from Brandmotion. He'll be talking about their lessons learned from onboard unit installation. And then we'll be wrapping up with Tony English of Niara Consulting, discussing the Wyoming DOT connected vehicle pilot experiences and lessons learned. So a little bit of background about the SPaT Challenge for those of you who may not joined us in the past. The basis of the SPaT Challenge is to broadcast SPaT messages and map messages at intersections using DSRC dedicated short-range communications technologies. And then with the understanding that follow-up efforts might include broadcasting a security certificate using the Security Credential Management System, broadcasting a GPS correction message or RTCM message, installing onboard units in vehicles as maybe part of the Fleet Challenge, or implementing other V2I applications. The SPaT Challenge began a couple years ago with the idea to challenge state and local public sector transportation infrastructure owner-operators to deploy DSRC infrastructure with SPaT and map broadcast in at least one corridor network in each state by January of 2020. We have reached that date. Here we are, January 2020, with the goal of 20 intersections in 50 states. After 3 years, we have 47 locations in 27 states, with about 670 roadside units operating and another 3,300 plans. And now, as part of the Connected Fleet Challenge, we've been tracking and know that there are about 9,200 vehicles planned to connect with that existing and planned roadside unit infrastructure. So we've had a lot of progress in the last 3 years, and would like to make sure that's acknowledged as part of this webinar. The SPaT Challenge has a website here that's transportationops.org/SPaT Challenge. Of course, we would love to hear from you if you are a part of an agency or supporting contractor that's helping to deploy the SPaT infrastructure, and getting the word out there would be great for us to understand what's happening out there. And if you've already contacted us, we'd love to hear any updates that you might have about from maybe things that have changed from when you initially contacted us about your plans, or let us know that you're operational. We'd love to hear from you. There's a email there on the website, noco@transportationops.org, where you can contact us directly or through the website, either way. As I mentioned, this is the third Connected Fleet Challenge webinar. We started off with 10 SPaT Challenge webinars that took place from March 2018 through January of last year, and this is the third Connected Fleet webinar, and that's the last one that we have planned. And we've had the series take place here starting in October, and all those recordings are available in full on the SPaT Challenge website or by topic. So if you're interested in only hearing from that one presentation, you don't have to listen all the way through to the end. We have those broken out, so it's pretty easy to access to get to the topic that might be of interest to you. The first 10 webinars, the SPaT Challenge webinars, we talked a lot about a variety of activities, and even though that might have been a year or so ago, I think a lot of those topics are still relevant today for agencies that are beginning a deployment. We talked about design considerations and the deployment and validation of your different installations, and then we heard from a variety of agencies about that were already operational, about their experiences and lessons learned. As part of the Connected Fleet Challenge back in October, we continued that with that spirit of things and focusing more on the vehicle side. We've heard from PennDOT and the FIA Connected Vehicle Pilot down in Tampa, as well as New Hampshire DOT on their SPaT deployment. This most recent webinar we had in December, we heard from New York City's experiences on data collection and onboard unit lessons learned, as well as from Jay Parikh at CAMP about testing vehicle-to-infrastructure broadcast for compatibility with onboard applications, as well as Rob Zimmer of Panasonic deploying V2X technology in fleet vehicles. On the SPaT Challenge website, I mentioned that earlier, there's a lot of resources available to you, and a screenshot of that is shown here. There's different, you can download the SPaT Challenge verification document. If we do have any more SPaT Challenge webinars, any information on that would be available at that one link there at the bottom. And as I said, all the recordings are available, as well as the presentations from those. We have a variety of resources on the resources page here, and we continue to update those as we receive new information. And then we also have a Connected Fleet Challenge website, which provides a little bit of an overview of the Connected Fleet Challenge, as well as some different resources. We'd like to, as I said, for this effort too, we'd like to hear from agencies. So we're working to create a map of different fleet deployments that are out there. There's a nice online form that you can fill out if you work with an agency that's deploying connected fleets. We'd love to get that information up and available. And when we do deploy the map, it'll be a little different than the SPaT Challenge. We plan to have it in a way that you can filter out the information that might be most useful to you. For example, if you want to filter out specifically snowplows or transit vehicles, there will be a way to do that. And then with the idea of make and model might also be separate as well to really hone down to the information that would be most useful to agency contacts that might be of most relevant to what you're looking at doing at your agency. As I mentioned, resources, we're still collecting those from different deployments, and we have that available on the Connected Fleet Challenge currently, but we're still working to collect that information. We think the best source of information we have is the experiences of agencies that have already deployed for the SPaT challenge or for connected fleets. And so any information that you have access to that, along the systems engineering V diagram that you think might be of interest or might be helpful for other agencies that are starting on this so that we don't have to reinvent the wheel each time, that would be really helpful for us here to collect and assemble that documentation and make it available on the website. So as I said, any information you have, feel free to pass that along. Procurement or bid specifications, cost information, lessons learned, all that stuff would be of great value to us, as well as any information you have for us to put on the website for the maps to help us understand the current status of deployments. As I mentioned, this is the last webinar that we have planned as part of the Connected Fleet Challenge. That's not to say it will be the last, but this is the last one we have planned. We encourage everyone to stay engaged with the CAT Coalition. These activities are under the umbrella of the Strategic Initiatives Working Group. There's also a Technical Resources Working Group and Peer Exchange and Outreach Working Group that if you're interested in joining, feel free to contact us and we'll get you connected to those groups. You can contact either through the NOCO webpage or contact me directly, and we'll get you on those mailing lists so that you can be involved with the CAT Coalition as we move forward in this time of advancing and the continually evolving technologies and to the next steps as we move forward here to continue the Connected Fleet Challenge and beyond. And so with that, I'm going to turn it over to Asfand Siddiqui, and he will talk about his experiences with Caltrans.
Asfand, you might be on mute. I believe we don't hear you.
Well, good morning. I'm just waiting for the presentation to show up on my machine. There. Now it's there. Thank you. Thank you. So, good morning to all of you from California. We are having a bit cold day here in Sacramento. Generally, it's a little bit warmer, but today it's a bit colder. I hope everybody else is having a good day in whatever city they are. So, good morning from Caltrans. My name is Asfand Siddiqui. I'll be talking about what Caltrans is doing in basically installation of roadside equipment and trying to form partnerships to deploy some of the applications that are easily deployable, at least within the purview of Caltrans. So, as I said, my name is Asfand Siddiqui. I work for Division of Research, Innovation and System Information, and that's the division that has the charter to basically work on the connected and automated vehicle technology. So next slide. I guess I have the control, Neil, right? Perfect. Okay. So what you'll see today is you'll be looking at the RS installation efforts in Palo Alto testbed, which has been going on for quite some time. San Diego area, which is the AV proving ground, and we got funding through federal highways on that. And then the Orange County area, which is basically Caltrans funding. OBU installation efforts, you'll be seeing two applications that we're working on, and they should go active sometime this year. The Valley Transport Authority should be earlier than the bus on shoulder, and then I'll be talking about lessons learned on doing all this. So let's talk about the Palo Alto testbed, and probably some of you already know about it, and the others may not. But so this was established back in 2005 when Federal Highways asked us to establish a testbed. We started working on it. We selected the Palo Alto area because, and we selected Highway 82, which is also known as El Camino Real. It was selected because it's right in the heart of the Silicon Valley, so all the tech companies are around it. And this corridor was selected because it has a high traffic on it. AADT is about 50,000. So and so it's the Palo Alto testbed is a partnership. When it was started, it was a partnership between Caltrans, UC Berkeley PATH program, and the MTC, which is the local metropolitan transportation agency. It was started initially with 11 intersections. Now we have 16 intersections that are broadcasting SPaT, MAP, RTCM, and RSM messages. It also accepts the BSM and the service request message. We are working with a private company. I cannot name them at the moment, but once it's done, you will see it on our website. So we are trying to implement the security credential management system. That work is in progress. And 15 additional intersections are planned. So with that, 15 additional and 16 existing, we will have 31 intersections consecutive. And this will bring the combined length of the testbed to 7 miles. And all these intersections are consecutive. So if you are testing an application, you will be seeing all these signalized intersections working as basically broadcasting SPaT, MAP, and RTCM messages. At the moment, we are developing 3 applications. One is the red light violation warning over cellular. The other one is the conditional PSP. That's we are working in conjunction with the Valley Transportation Authority, which is the local bus company. But that's the DSRC based. And then we are also working on transit eco approach and departure, again with Valley Transport Authority. Again, it's a DSRC based. Then the last one is the reduced speed zone and lane closure warning. That's also DSRC based. But the last one is we don't have a partner for it. We are developing it in-house. Okay. The other one is the second one, which comes under the purview of Caltrans, is the San Diego area, which is our District 11. This is they got funding. District 11 got funding through, well, not District 11. It was SANDAG initially that got the funding. The later the project was transferred to Caltrans. This is a collaboration between SANDAG, Caltrans, and City of Chula Vista. And if you look on the right, you'll see. So this is an AD proving ground. This is not connected and automated vehicle. So there is like a difference in flavor of what we are doing in Palo Alto. So if you see on your right, you'll see the line in the red, which is the I-15 express lane. We are installing RSUs on this highway, as opposed to an arterial, which is the one in Palo Alto is an arterial. This is highway. We are also doing work under State Route 125, which is practically at the border of Mexico. And then the light green area is the City of Chula Vista. That's we are also developing, installing RSUs and developing applications in that area. So 25 RSUs are planned to be installed by June of 2020 on I-15, which is the red area. I hope you guys can see my cursor on the diagram. Can you guys? Can you?
I believe not, but
okay.
there's a green marker that you can move around.
Oh, I did not know that. Okay, thank you. All right. So this red area is the I-15 express lanes. We are installing 20 RSUs there. And then 10 onboard units are planned to be installed on Caltrans maintenance vehicle. And the planned applications in this area, these are in planning stage, are the D2X Q warning and D2X expanded CMS messages. And as the name suggests, Q warning is basically you'll be, if the traffic is building up in front of you, you will be receiving safety message using your OBU in vehicle that there's a queue is forming in front of you. You better slow down. The other one is the expanded CMS messages. So if you have an OBU, the RSU will be giving you information on your head unit inside the car. The third one is the Orange County area. And they're installing 120 RSUs. This is in design stage. I was told a couple of days ago that plans and specs are ready. They will be advertising it for basically for construction. And you can see this triangle area. This is Highway 5, this is 57, and this is 91. So on these three freeways, there are CCTV cameras already there that provide information to Caltrans TMCs. So wherever we have the CCTV camera, we'll be installing an RSU. Not to say that we have 120 cameras there. So all the CCTV locations will have an RSU plus additional locations. Then we have 52 additional RSUs that are they'll be installed on the on Caltrans right-of-way. So all the roads and intersections that comes under the purview of Caltrans, mainly the RPF, we'll be installing 52 additional RSUs there. This work is programmed to be completed in September, October of this year. At the moment, the local engineers, they are more focused on installing the RSUs. They are not giving a lot of focus on applications, although they're thinking about it. We have a couple of discussions with them. So at the moment, they're simply thinking about accepting the BSM message that is broadcasted by the vehicle, and then take that information to TMC. Okay. So as I said, Caltrans is an owner-operator of infrastructure. So we are infrastructure heavy when it comes to installation of RSUs. Our challenge is to find partners who can who have vehicles on the road so that we can develop applications with them. Caltrans has maintenance vehicles. They can be used to do certain applications, which will be transportation agency related only. But we want to go out and have partners who can work with us to develop applications where they can use the information coming from the infrastructure, or perhaps they can provide information to us that their vehicles have. So at the moment, we are working with the Valley Transportation Authority to develop a conditional transit signal priority. The information that you see here is basically a readout from our it's basically a computer readout, which was not done on a bus, but it was done on a car, basically to see that OBU is communicating with the RSU and the signal priority is being granted. This has not been installed on the bus, and this was tested not using DSRC, but the 4G LTE technology. However, the OBU has been tested to communicate the same information, and once it will be installed on the Route 22 buses that are operated by Valley Transport Authority, this will be one of the applications that will be deployed. Valley Transport Authority is interested in deploying this technology on their buses once the RSUs are widely available. The transit signal priority is conditional, meaning that the RSU will give priority based on predefined policies. And those policies are defined by the bus company. At the moment, they are thinking about that there needs to be a certain number of passengers in the bus before the bus becomes, before the bus should get the signal priority. And the second thing is that there should be enough traffic on the road before the transitional priority should be given. If there's not, then the bus just should run on its predefined schedule. This is the other implementation that's being designed, or it's actually being designed at the moment. This is being done in District 11, which is, I have to go back, I'll show you, which is on Highway, it's actually on Highway 94, close to the city of Chula Vista. That's where it's, I'm sorry, it's south of, it's west of Highway 805 on Highway 94. That's where this application is being planned. This application is unique in a sense that at the peak time, we will allow buses to run on the shoulder. Now, once the bus is going on the shoulder, the bus OBU will be sending out a request to the on-ramp controller to stop the traffic or hold the traffic till the bus clears the predefined geofence area. So once the bus entered the predefined geofence area, and if the bus is on the shoulder, it's going to trigger, it's going to send a request to the the on-ramp controller to basically hold the traffic. And then once it leaves that area, the other message will go to basically start releasing the traffic to come to basically join the highway. The RC design is complete. We are developing or upgrading the software for the ramp controller, which is a 2070 controller. And this system will only work at commute times or if the general purpose lanes are running below the 35 miles per hour. Okay, so lessons learned, I call it the understanding upgrade. So every time you work on these technologies, your understanding level goes up. And we, as an agency, have some unique issues that some of you may not face. So the software update. Caltrans uses its own traffic signal controller software. Caltrans has, although we use 2070 controllers, but all the software is owned by Caltrans. And that brings an issue that if we need quick updates, sometimes all the engineers are busy with their regular day jobs, and we bring in a request, and sometimes these requests are delayed based because they have something more important on their hands. So that's an issue. So some of the issues that we ran into are just to connect the 2070 controller to the DSRC radio, and it was an issue for us because due to security reasons, all the ports on the 2070 controllers were basically disabled. So once we started it a couple of years ago, we had to work with the traffic operations and the group that works with the software, 2070 software group, to basically open the ports and then basically make the ports such that it only dumps the information out. At one point in time, we are simply dumping all the register information to the mid machine, which is in between the DSRC control, the DSRC radio and the traffic controller. And that so there's a computer that sits between the DSRC radio and the 2070 controller, and that computer runs all the CAV applications. And that computer also creates a firewall so that nobody can go through the DSRC radio to the 2070 controller, although at one point in time, 2070 controller was simply outputting the data. At the moment, we can accept information from this computer, what we call the MIT computer, So at the moment, the software can take a PED request. So if either you can push the PED button on the intersection, or if you have the application on the phone, which we have tried and tested, you can send a request using your phone. But that phone connects to the DSRC radio using Wi-Fi, not the DSRC, because we believe there is no phone out there that has the DSRC radio on it. Anyway, so the other issue is the ramp metering software. I mean, ramp metering is lately Caltrans is using coordinated ramp metering. But that software needs to be updated such that it should be able to receive the requests from the bus, especially for the bus and shoulder project, so that it holds off the traffic. Although simple, it looks simple, but then again, it impacts the engineers who are doing their daily work, and sometimes it gets slowed down. However, that thing is work in progress. But this issue is unique to Caltrans. I don't think if you're using a vendor who basically updates your hardware and software, then that should not be an issue. The other thing that we are diligently working on is to remove that computer that sits between the DSRC radio and the 2070 controller. So what we are doing at the moment is to come up with a new spec for Caltrans spec 2070 controller that can handle more than one CPU card. There are solutions out there in the market for the 2070 controllers that can have more than one CPU. This is unique, where one CPU will be running the OS 9, because our traffic signal control program uses OS 9, and the other CPU will be running a Linux-based system, because all the CAV applications are Linux-based. That's the interim solution, and then the ultimate solution is to have two CPUs running both Linux, but then that gives us another challenge to port the traffic signal control program that Caltrans owns and port it from OS 9 to Linux. That is also work in progress. So ultimately, Caltrans will have a two CPU solution where we'll have two CPU cards. One is running traffic signal control program, and the other will be running the CAV application. And we bifurcate them because if for some reason CAV applications go down, it should not bring down the whole intersection into flashing red, so that the traffic signal control program keeps working, even if there's an issue with the CAV application. So the Caltrans spec is ready, and I think it will get published sometime in March this year. Once it gets published, we are working with a manufacturer to have to basically manufacture 2070 spec hardware for us, so that we can install it on the 16 additional intersections on the Palo Alto test bed. So that's the plan. Then the story of constricted conduits. If you have obviously you have existing infrastructure, your existing signalized intersections, and if they're built 15, 20 years ago, you may run into this issue where the conduits are already filled to the capacity, and pulling more cables could be challenging. And we ran into that situation on our test bed in Palo Alto. At one particular incident I like to share with all of you is that we had a situation where the pull box was about 8 feet away from the traffic controller cabinet. But to do that, we had to dig it up, replace because the conduit was practically filled to the limit. So we had to break the concrete, dig it up, put the signalized intersection into red flashing, replace the conduit, and then basically make it work again, just to add 2 more Ethernet cables. And so a small thing becoming a big issue. That could happen. The backhaul availability. We like all the intersections to be connected using the fiber backhaul. At the moment, we are using a 4G LTE backhaul, which is working fine. But on the Palo Alto testbed, we have fiber running on one side of the roadway. That brings up the issue of if your traffic controller cabinet happens to be on the other side of the roadway, then you need to bring fiber crossing the road, and in this case, road becomes a barrier. On one particular intersection, when I talked to the local design engineer saying, hey, how much would it cost to bring the fiber from one side of the road to the other, the answer was $30,000. And if you have a couple of them, it adds up fairly quickly. So that's the other issue that we are running into. And then last but not the least, obviously everybody on this forum is fairly aware of what's happening with FCC and what's happening between the two standards, DSRC versus DB2X. For all the projects that you have heard so far, where we are installing hundreds of RSUs, the idea is that we are going to do all the groundwork, basically be ready to just hang the radio on the poles, and by then this standard issue will be settled, and regardless of what standard comes out of it, we will go with that. So that's the standing order. At the moment, if you drive on Palo Alto testbed, you will be seeing DSRC radios, but if the standard changes, we will also change to that. So that's our position on that issue. And that's all I have, Jeremy.
Thank you, Asfand. Next, we have Rafal.
Thank you. I'll wait a little bit until my slides show up. There we go. So I'm Rafal Ignatowicz. I'm the Product Development Manager and the CV Technical Lead for Brandmotion. And I'm here to talk to you guys about the foundations for integration of connected vehicle equipment into the actual vehicles and the lessons learned throughout the deployments we've done so far. So who are we? Like, we're a small company. We're actually vehicle integrators. Most of you know us as vehicle integrators for different pilots, project deployments that deal with connected vehicle technology. Here's just a few of them that we've been involved in, that we've helped in, that we installed on vehicles. At this point, we have about, I think, 11 or 1,200 vehicles that we installed on so far, with a lot more planned in the next few months, and we'll continue expanding that. And that's just for government and smart cities, smart city deployments. One quote that we like to share with everybody is that what Bob Fry said in Tampa is, don't try to handle OBUs, hire automotive professionals to manage. There's a lot of work involved in equipping vehicles, and it doesn't seem as simple as the intersections. But vehicle integrations is just one portion of our whole business. So how does it all fit together, and why were we chosen for all of this? Is because our main business model is to develop and provide solutions, advanced retrofit safety solutions for the North American aftermarket. So we do anything from blind spots and backup cameras to parking sensors and collision avoidance for the aftermarket. So if your car didn't come with one of those features that the brand new cars come with, we're there to help. So our main motto is safety first, and that's what we've been doing, and that's how connected vehicles really fit into it, because we want to make sure that the vehicles out there on the road are safe as well as the new ones that are coming out. The second business portion is custom advanced technology demonstration vehicle builds, so for shows, for integration of autonomous features to the cars that are already there. We're working with tier 1s and OEMs on that. And then the last one, as I mentioned, is the connected vehicle and smart city integration and deployment services, which most of you know us by. And how does it all fit into our vision and mission? Our vision is to see every vehicle on the road equipped with crash-avoiding, life-saving technology. There's 35,000 vehicle deaths, people dying on the road, 35,000 of them every year, and it's a number that we want to decrease to zero over time, but we can't do that without adding equipment to cars that are already on the road that manufacturers are already putting on the brand new cars. And then our mission is to lead that national retrofit approach to safer vehicles. In our time in the connected vehicle spectrum, we came up with 4 things that we focus on in order to make it a successful deployment pilot or whatever it is for connected vehicle technology. And it's the first one is how this information is going to be presented to the driver with human-machine interface. What vehicles are going to be used? Do you have the right people for the job to install all of this equipment? And are you ready for what will happen after the installations are complete? So those are the 4 major things that we always look for and make sure that they're set before we start any of these of this CV work. So let's go to the first one, the HMI considerations. So what we generally look into is 2 things: is that to make sure that the driver is not distracted while giving them the most information as possible in as little time as possible. So it's kind of contradicting a little bit because you have to distract the driver a little bit in order to get their attention for something else, for a warning, for a collision warning, for an emergency electronic brake alert ahead, or that they're going the wrong way, but without distracting them too much that they take their eyes off the road. So a lot of information in a little time so that they keep attention to their main task. Using Tampa as example, the Tampa Connected Vehicle Pilot, we developed the hardware for that. I think this was the first project really that used it on participant vehicles and not in demo cars, and it was something that we needed to integrate into every vehicle out there. So you probably have seen similar things to this picture where in demos, usually manufacturers of this equipment use tablets that are suction cupped to the windshield or suction cupped to the dashboard somewhere. They're added to the car, and while this is great for the demo and showing up the technology to sell it, this is not the optimal way to present it to every driver if we were to put it in 1,000 cars. The biggest reason is it obstructs your view more than it helps, actually. Creates a small blind spot that the person behind it could have hidden. It also creates a risk. If in case of a crash, that thing could be flying at you because it's just suction cup. There's no security. Also, the cables running around can tangle up and get caught up somewhere. So we decided this is not a right approach for mass market. And in Tampa, we integrated the display into the mirror itself so that it's still in the field of view of the driver, but it's not distracting to a point, and it's not obstructing the view or anything of that sort. So that's the way we went forward in Tampa, and that was a big lesson learned that I think other pilots or other deployments started thinking about how to display these things to the driver. But over the time, and talking to other deployments, pilots, and governments, we found out that that's not a one-size-fits-all solution. So that's just one of the ways to display warnings to the driver. And that's the most integrated way, I would say, because it's not adding any equipment. It's just replacing one piece of equipment, and it looks stock, like the car was made like that from factory. But some cars won't be able to use that. So on buses in Tampa, for example, we used monitors that were mounted to the dashboard for a driver to see the warnings. And it's larger at that point. For a larger vehicle where the driver is farther away, it would be easier to see. We've also developed heads-up displays in order to have it right in front of the driver's vision instead of a little bit to the side. So this is an improvement on top of the mirror where the warning would come right in front and the driver wouldn't even have to move their eyes off the road. And then because not every deployment needs a visual warning per se, one of the things that we developed for a simpler HMI yet effective and lower cost would be an LED light bar that would shine light at the windshield and reflect it off of it, similar to some of what latest OEMs are doing with forward collision warnings or advanced braking assistance in their cars, where they flash it and so the driver can see it. So just a couple ways to present it to the driver, but it's not about only the driver how the warnings are presented, but you have to design for them. That's another big thing that we did in Tampa and learned a lot from it, is that you can't just say, here's a graphic and please make sure that it triggers when the car is going the wrong way, because there's so many different scenarios that have to be thought about. You get the requirements from your customer, and they say, yeah, we need it to work this way, but it doesn't really specify how it has to work. So that's where we came in and designed scenarios for all the applications of when each warning has to trigger in what situation. So there is a wrong way entry ramp that is reversible in Tampa, which is a really complex intersection, and it closes part of the day and it opens the second part of the day. It goes one way in the morning, goes the other way in the afternoon, with many ramps coming into and people going the wrong way all the time. So I think we had 16 different scenarios listed for this one, and for each one we designed the application so that the application would take into consideration these different scenarios and how it would work. And if for example, it came the wrong way, it would get a multi-stage approach of warnings as well. So after the scenarios were concluded, we would need to also design the graphics that were shown to the drivers, and that took a bunch of effort to get it just right. And that's another big lesson learned, where we would get the OBUs from manufacturers, and they used different graphics in demos that were very descriptive, I would say, and were very clear, but they had too much information per se on it, and they were not easy to understand by a driver or by the person that it was being demoed. So what we did here was we combined US DOT road signage with symbols based on the ISO 2575 design practices standard, and designed these graphics for the different applications that were used for Tampa. These can be modified obviously to other deployments and based on the need of applications, but these are the ones that we used there. And besides that, not only do you need the graphics, you need to prioritize the warnings. The priority, as you can see on this graphic, it's prioritized where pedestrian comes really first, because they're the most vulnerable user of the road, followed by the immediate action applications that you need to take immediate action, like for collision warning or intersection movement assist, followed by the wrong way entry, the vehicle turning right in front of the transit vehicle, EBL, and finally ERDW, which involves a couple of just advisory informations. So we used the standard, the SAE J2395, to determine the message priority, but it wasn't really clear. So we had to we had to sit down with the team and decide how do we want to prioritize so it makes sense. And the app with the highest priority obviously is going to display first and overpower any other application that works at the same time. So, for example, you could be going, the end of the ramp deceleration warning could pop up, but you would also get a car braking up ahead in front of you, a couple cars down, but then immediately in front of you, you have a forward collision warning. So the forward collision warning would display first. So there's logic that had to be implemented into that. And on the beginning, it didn't really work well, and all of them started flashing. But over time, we got it down with the OBU providers to figure that out. So that wasn't done really before, and because usually demos work with one application at a time. So that was the HMI. The second portion, and this is where our knowledge really came in handy, was the vehicle variety challenges. In Tampa, we had to install on 1,600 vehicles, and most of them were supposed to be from just volunteers that came off the street that wanted to be a part of the pilot. And the challenge with that was when we got the initial list, I think there was a total of 370 or so variations of vehicles in itself. So you have years, makes, models, trim levels, all of them are different, and you can't really use a one-size-fits-all formula for any of it. You can't really say all the sedans are going to be installed this way, all the SUVs this way, all the trucks, passenger cars, and all of that. It's all different. So that was the biggest challenge, the uniqueness of each car coming into our installation facility. The second portion was informational readiness. So even if we had information from the participant ahead of time or from the fleet vehicle ahead of time saying this is going to be an Ford F-150 from 2015, and that's the car that we're going to be installing on, we need to prepare the installation, prepare information on that. So wiring diagrams had to be prepared in advance to save time. Sometimes you wouldn't be able to get that information because it was a brand new vehicle. Let's say it's a 2020 new Ford that we haven't seen, and there's no guides online about it that are provided from the manufacturer yet because it's too brand new of a vehicle. At that point, we would have to improvise. Also, high-end vehicles that have a lot of different systems on them that might have, wiring diagrams are so in-depth that you wouldn't be able to find the right information or are lacking the information because the manufacturer doesn't want to share too much about it. So informational readiness was a big lesson learned that I'll speak about this in the next slide about the installers that are needed for this in order to overcome this challenge. Another big one was availability of the vehicles themselves. So we had to coordinate with different agencies. You had transit agencies, you had city fleets, different kinds of fleets for freight, and coordination with them is not easy because the cars are not owned by one person. You can't just contact, hey, can you bring me your car over here, like we did with participants. It's per person basis. Here you're trying to coordinate with a fleet manager that has his own supervisors that each have their employees driving different cars and getting down to that level. And I think Rob Zimmer actually mentioned this in his presentation. Was a big issue and challenge that we had to face to try to organize it. And as my third bullet on that one says, having spare or reserve cars in case of that happening, not getting the cars is a much needed thing for installation, because you're there, you have the installers ready, you have the technicians ready, but you don't have a car, and you have to go through 1,000 vehicles to install within a couple months, and without having spares, it's going to be hard, especially with the coordination. And timing of installation is another thing. As I said, uniqueness of the cars is very vast, and the installation can't be, you could have a window of 2 hours. That's what we had for passenger vehicles in Tampa. But once you go to, let's say, snow plows, that you would have to have probably 3 hours. Buses and streetcars, 3 to 4 hours. Fleet vehicles, depending on what kind, it's also. But even in the passenger vehicles, there's some things that you would not think of, but have to be taken into account. You might have 2 Ford Escapes, for example. Same thing, you have it on your schedule, but one comes in, you get it down in an hour and a half, but the second one comes in and it has, let's say, a bunch of stuff in it on the back seat or the front seat or in the trunk that you have to take out to dig into it, to find the wires that you need to. Let's say one of them is actually a key, where you have to turn the key when you turn it into ignition, and the second one is a push to start, which changes everything completely, how you wire the equipment into those cars. So having that knowledge ahead of time, the information and readiness goes back to that, could change the timing of the installation tremendously, which it did, based on what we found out. Additional equipment that's needed. So because, again, of the uniqueness of the cars, wire lengths for the equipment have to be changed. Usually when you buy these OBUs from the manufacturer, they come with a short harness, and you have to modify it or extend it in order to make it work with the car that you have. Sometimes they don't even come with the wire harnesses, and you have to source it separately because it's based on the vehicle needs, and the OBU manufacturer might not know what vehicle you're going to be installing it in, so you have to source it separately. Power converters and relays. All the OBUs that we've worked with, and we've had, I think, 6 different manufacturers that we worked with at this point, have pretty much the same one requirement, and that's 12-volt input for power, which is a standard voltage for any car that's on the road. But some fleet cars or buses, and definitely street cars, don't have that kind of power in it. They have high voltage, at which point we would need to source additional power converters and relays in order to make the OBU work and not fry up because of too much power. And the last thing here is already existing aftermarket equipment. Some cars, especially fleets, have already stuff installed. That could be for telematics, that could be for GPS tracking, that could be for any other reasons in there, and you have to work with that. So you can't trigger it. You have to make sure that the OBU functions correctly. So especially like Bob, I think, mentioned in his presentation on New York, dealing with CAN when the OBUs have to be connected to the CAN bus of the vehicle, you have to make sure that you connect it in a way where it's just reading and it's not inputting information onto the CAN bus, because it's going to be triggered. These extra equipment, aftermarket equipment, are going to be triggered, which is bad. So you have to be knowledgeable about that and have that information ready from the fleet managers or from whoever that you're installing on. So that's a big thing to do ahead of time. On to the next slide. So beyond the vehicles, the next thing is to be sure that you have the right people to do the job. And at Brandmotion, we've been working with students at HCC, the Hillsborough Community College in Tampa, where we trained them, we certified them. we've worked with other installers around the country for our the other portions of the business where we do the aftermarket equipment. So we have a vast base of installers that we've trained, and we found out that definitely need to, for connected vehicle technology, you need to have people that have experience and are certified. And it's not about the ASE certification that a lot of mechanics have. It's actually about the deep knowledge of electrical systems and vehicle interiors. So most of this equipment, all of this equipment that goes into connected vehicle technology is based on electrical. So you have to make sure that the person that's installing knows the electrical systems of the car, maybe even data systems of the car, so that when they connect it, it's not gonna cause the fuse to go out, or to make the car not start in the future, or to drain the battery. And then the second point I made here was the vehicle interiors, because you're not just putting the equipment and plugging into a cigarette lighter port. You actually have to take panels off to route the cables so that the cables are not all over the place. You have to, as the picture in the below shows, usually the OBU would be in the trunk or under the front seat, and the mirror or the display would be up front too. You have to run things to the back, and you have to hide them in a way where if a participant or the fleet manager or whoever uses the vehicle, they're not, when they're putting stuff in the trunk, they're not going to move anything. They're not going to disconnect anything. So knowing vehicle interiors is a big must here. Second thing, these technicians are quick learners and open to learning about new technology. As we know, this is a brand new market really that started a couple years ago. You can't really buy this equipment off the shelf in your Best Buy or your Car Toys where you can install yourself. So a lot of installers and technicians don't know about this and have never seen it, but we would like them to be very open to learning about it and not closed in about one specific thing that they've done before, where that's how the radios should be connected, for example. We've had issues before where they would get stuck to their ways, essentially, and would like to install it their way. But with new technology, you have to develop new ways to integrate it into the vehicle, and people that are willing to take direction from us as certified in the field is a big plus. Third thing, resourcefulness. A lot of the times, as I mentioned earlier, information might not be available readily for a particular vehicle, and they would have to improvise on the spot. Happened a lot in Tampa. It's happening in other deployments as well, where you have a certain window of time that you have to install it in. You can't really call anybody. You can look online for some guides and manuals to diagnose, but in the end, you might have to try different things by yourself and see what works and what's making it run into trouble, and solve it yourself. So that's a big thing that we ran into, and we're happy that our people that we use were very resourceful. And the last thing, which is kind of a little different, that you would not expect this from a technician, is to be a people person. So we ran into a couple things where a participant would be really needing it, or a customer really needed it right now, or did not understand what's happening to their vehicle. Why are we taking it all apart? Why do we need to go in here? Why do we need to go in here? So the person has to be essentially patient and have great communication skills, where they can explain it in simple terms, essentially, what they're doing, so that the end customer or the person that we're giving the vehicle to at the end knows what happened, that they understand it, that they're not really, that in the end they know what this technology does. So that's why I posted it here, as a people person would be definitely something that's not usually looked for in a technician, but it would be definitely helpful. And then on to the last couple of slides that I have here, which involve post-installation issues that came up after the car has been installed, given to the customer, to the participant, to the end point that we gave it to. Essentially, we didn't wipe our hands clean, and that's it. We're never coming back to it. Because you need to offer support, especially with things that are still in development. Equipment, OBUs are still, again, they're not off the shelf. They're developed for a purpose, and there's a lot more testing to be involved here, I think. And issues will arise. No matter how you look at it, they will come up. So I got, I think, 5 over here that I wanted to give a heads up to others in this webinar that might be looking into equipment in their cars. The first one is, if you make this installation and not so permanent, water leaks might happen, especially since the antenna wires have to be run through from the outside to inside without drilling any holes. So antenna wiring routing has been an issue. One thing we learned, drip loops, making drip loops on the outside and double checking your work before you give it to the customer, and also use thinner antenna wires when possible. I know there's higher losses, but there's a trade-off essentially. You either can destroy a car or have slightly less reception. Battery draining, checking for engine lights ahead of time and checking battery condition ahead of installation, notifying the participant that there's weak battery, that you probably have to replace it within a year, that this is not, the equipment is going to not take that much off of it, but it might be worth looking into the new battery. We got blamed multiple times about the battery after checking a condition and telling the customer they need to change it anyway. Total vehicles and trade-ins. We noticed that if we install 1,000 cars, we're going to have about 3 to even 7% vehicle drop-off, where people crash their cars or trade them in or go move out of the area and we never see them again. That was unexpected, and the crashes are not due to our equipment actually, and they were. We contacted all the people and asked them what happened, and none of them involved a reason that equipment caused it. But it's something to be aware of. If you install it in the vehicle, you might have to reinstall it in the new vehicle in the future. And sometimes not having an ability to retrieve equipment was problematic as well. So if you want to collect data that way, you might not be able to because the unit got crashed. Equipment malfunctions. OTA, so over-the-air updates, as was mentioned before, is a great way to shoot out the updates into the OBUs that are out there on the roads, but it's not foolproof because some issues are going to arise that you can't fix with a over-the-air update, that you actually don't know what the issue could be. You just stop seeing cars, for example, going by the RSUs, and at that point you might have to call it in and see what's wrong. We found out that there's a bunch of issues that are not reported in the logs that are sent up, and calling back in the participant or going to the fleet manager and getting the car back is needed. So that's going to happen because again, the technology is not foolproof on that sort of thing. And then the other thing is, if something goes wrong in a car and somebody goes back to the dealership to try to fix it, the dealership will blame the aftermarket equipment for everything. That's a known fact. They will make any excuse and they will not show you proof. Once you start asking for proof, they will back up and say, oh, maybe it was us. That's a big lesson learned that we found out, that the participant or whoever we installed the car on, the equipment on, should contact us first. We'll take care of it, and then if it doesn't help, we'll take care of the dealership. but they should come to us first. And then last thing here, environmental factors. If you deploy for a year or two, you're going to have sun affecting the paint of the car because it's usually even around the car. You're not going to see it, but if you tape something to the roof and then peel it off, you're going to see the discoloration. So paint will fade. That's normal. Sometimes it will even peel because it's old paint. So I showed two examples down there that paint can peel, especially on older cars, and that's not something you can do anything about. It's just not do it on older cars, I would say. Also using automotive vinyl, kind of like what they use for stickers to advertise on the vehicles. That's the kind of vinyl you should use to stick anything to the top of the vehicle, side vehicle. And then hardware itself can degrade in some environments. If you deploy for 2 years or more, you might have this hardware degradation. So we used an AD problem-solving worksheet to talk to the manufacturers and suppliers to make sure that the equipment doesn't degrade in the future. So that's all I had. If you have any questions, please submit them on the question discussion pod. And I'll turn it over to Tony to present his slides.
Thank you. Give it just a second to come up here and try to get through these quickly so we can leave a little bit of time for questions. I'm Tony English, lead engineer for the Wyoming Connected Vehicle Pilot. I'm going to give a brief introduction to the pilot. We've got 402 miles of roadway, Interstate 80 through southern Wyoming, 400 instrumented vehicles, and then we're also tying in our connected vehicle data with our cell phone application, the 511 application. This is an overview of the system diagram. What's most relevant for this discussion is the vehicle system, and that's where the OBUs are tied in. It is a DSRC system, and the RSUs communicating with them. We do also have a satellite provider, SiriusXM, that we're also sending out our traveler information messages to the vehicle systems, and that really helps us get information out over the much broader area of our pilot zone. The main applications that we're running, we have forward collision warning, DSRC, through snowplows, and mostly heavy freight vehicles. We do have some light duty vehicles, but that's not the focus of our pilot. The onboard applications through satellite and RSU traveler information messages, these are going to give drivers alerts for situational awareness. So it might be snow or road closure, rain, fog, different types of alerts, parking information when the roads are closed for trucks to find areas to park. We have also created one interesting application that's new to the connected vehicle infrastructure. It's something we call distress notification. We have fairly large open roadways on I-80, 75, 80 mile an hour legal speed limits, and because of that, the DSRC range is not really adequate to get warnings out if you're having a 5, 10, 15, 20, 30, 40 vehicle pile up. The 300-meter range really doesn't work out for us. So we've got this distress notification where the vehicle 1, the one that's been in an accident, sends a message to vehicle 2 traveling the opposite way, and then the vehicle 2 carries that message well beyond the distressed vehicle. In our case, we've got it set up for 5 miles, and then the vehicle 3 gets that notification so that they're aware of the accident ahead. Now let me get into the issues and challenges. The top level discussions are trucks really aren't cars. Many of the standards and the solutions don't apply, at least not completely. And we are primarily focused on trucks. The data volume, that's a pretty big deal. How do you get the data back? How do you send the data out? And we'll go into slides, more detailed slides on each of these. The OBUs failing, they do seem to be not quite ready for prime time yet, and there is a lot of management and monitoring needing to be done of the OBUs. The SCMS adds quite a bit of complexity to the system, and building that out carefully is awfully important, and recommend deployers to leave a little bit of time to sort that out. GPSs and the IMU integration, the inertial measurement unit, is something that some of the vendors have had challenges with, and that's a bit of a something to really look into. And then the over-the-air updates. The DSRC is fairly low bandwidth. You might get 6 meg throughput on it, so at highway driving speeds, downloading the over-the-air updates while you're uploading logs is something that really needs to be looked at. The SCMS, really getting the profiles worked out between your SCMS provider and your vendors. It breaks a lot of stuff depending on how you're using your application certificates or pseudonym certificates. It's difficult to get those to work just right, and I'd recommend starting early and having a lot of communication between BlackBerry or ISS or whoever you're going to use and the vendors that you're pulling in. We found that there were more problems than we expected at very low levels of the integration. By that I mean, like the Qualcomm radio in one of our vendors, OBU was getting stuck on channels. So you're supposed to be able to do your channel switching. It failed in certain situations of high load, and we didn't expect to be troubleshooting that level of firmware issue, but we found that we really did need to troubleshoot those types of things, GPS, firmware issues that you'd figure were worked out by now that really just aren't. The log file issues has been something that we had to carefully engineer so that we could prioritize the logs that we really needed. So if there's available time and space, then we can get additional logs. But the priority of over-the-air updates and log offloads is something that's quite important to get right, and spend some time punching through the numbers on that. Managing the OBUs is difficult. We do have, we've embraced the changing of your MAC addresses, your IP addresses, and your pseudonym certificates. So the obfuscation is pretty real. It's very difficult to track vehicles, and because of that, it's hard to know when you've got broken vehicles on the roadway. Really, we're finding that we just need to do tests with our different fleet managers to make sure things are working. And outside of that, we can just statistically look at the number of vehicles we see on the roadway to figure out if we've got major problems with OBUs. Network security is kind of a big deal. You're allowing potentially bad actors to have an OBU, and that OBU is communicating with your TMC. So figuring out how you're going to bastion that out, how you're going to work with IPv6, which is really the only IP networking that OBUs are going to talk on. You have WSMP for the vehicle-to-vehicle and vehicle-to-infrastructure, but IPv6 is really how you're going to be downloading your certs and offloading logs and things like that. And getting that worked out with the routers and firewalls is a bit of a challenge for most. There's a few different approaches to integrate that with tunneling or going native, but a lot of things to think about there. The SRC shadows for trucks is a big deal. The antennas for cars don't really work on semis, and on I-80 it's 50 to 75% semis, and we had to do quite a bit of work in figuring out where we could put the antennas to get them to work. The single shark fins really are non-functional on trucks, and if folks are deploying on semis or snowplows, let me know. I've got some reports on that, but it's a little bit tricky to get that right, and some of those then antenna wires just don't work on trucks because you need the extra length to get the antennas posted, and that requires a little bit heavier cabling to get those distances. Truck articulation's kind of a big deal. If you treat a truck as a large car, it doesn't behave that way, and you can end up having some very odd forward collision warning messages. So Wyoming, as well as the other two pilots, have agreed to use BSM Part 2 for the basic safety message to describe the trailers, and BSM Part 1 to describe the power unit or the tractor. And that has quite a few ramifications. And it's kind of important to start migrating towards the use of BSM Part 2 for pivot points and trailers, and we've got some reports on that as well for deployers that are headed that way. Vendors work with them often, work with them regularly, make sure that you have good system requirements. The OBUs really aren't something you can order on Amazon Prime and expect them to work right. It takes a significant amount of system engineering and documentation to really get something that's going to behave the way you want it to, the way you expect it to in a deployment area. Data volumes are absolutely enormous on the data center side, as well as the DSRC or cellular V2X backhaul. Really look into that, make sure you engineer a solution that can support that large data. We're finding Hadoop-type solutions are working much better than SQL-type solutions. It's just too much data. And finally, resources. We've got a monitor that's fairly interesting. It's open to the public, and with that you can see the vehicles traversing the RSUs for the Wyoming Connected Vehicle Pilot, the status of the RSUs, and the traveler information messages that are pushed out. That's all I've got, so we can move into questions now.
Thank you very much, Tony. Now we can turn to question and answer section of the webinar. I do see one question and discussion between Robert and Asfand. I think that Asfand already sort of answered that, but I guess until people start writing their questions, Asfand, did you want to summarize your answer, and if you have any additional thoughts to add to what you wrote?
Okay, so the question came from Robert Rausch about how when we are doing the transit signal priority, how the policies will be implemented. The way we have envisioned is that obviously policies are dictated by the Valley Transport Authority, that when or like if and when they need signal priority. So if the bus is running late and the position is known to the VTA headquarters, and if they know that the bus is late, then the buses will be making the signal priority anyway, signal priority call to the using the DSRC equipment anyway. Now, whether the call is answered or not, that's a different story. So the RSU will receive the call or receive the request for signal priority. Before that request is passed on to the traffic controller, the RSU will look at the predetermined policy for that day, or perhaps for that time period within a day. If it doesn't have it, it will communicate with the bus company to get the policy for that time, and then based on that policy, it will make a decision. One of the interesting things that we came across is that the bus company wants to know how many passengers are in the bus. That's an interesting research topic that we don't know how to solve that. But they're saying that if there's the number of passengers in a bus is below a certain threshold, and the threshold is 5, then they don't need to do the signal priority, because once you do the signal priority, you are basically interrupting the traffic cycle. So they do not want to interrupt the traffic cycle. They want to let it run if the number of passengers are below 5. If it is over 5, then they want signal priority of it. So that's one thing in the policy. I'm sure there's more to it, and we are working closely with them in order to to understand what is it that they need. But the RSU is basically a communicating device which will be talking to the bus company's system to get what policy is being implemented for that time. And that's our understanding at this moment.
Thank you, Asfand. I see people typing on and off, so I don't see any more at the moment, but I encourage everyone to type their questions. And while we're waiting, any of the panelists, I don't know if you had any questions from other people, or Jeremy, if you had anything to mention, you are all welcome to say it now.
I can also tell the group about the something that was asked, and I didn't include it in my presentation, is the validation tool, which is the well, we end up using the eTrans SPaT map validation tool on our testbed, which we received from CAMP. Since I did not include any slides on that particular issue because that project was not done under Caltrans purview. It was done by different funding. Since the contractor is the same, I was able to get information from them, but I didn't put it in the slides because it's not really our work. However, I can tell you that the tool worked flawless. We basically took it out of the box, set it up, and then we started running with that tool on our test bed, and there were no issues in communicating, receiving SPaT map messages, and basically broadcasting the PSM, and then making sure that the PSM is getting to the RSU. So no issues at all. There was a minor issue, which was basically that this is the speed limit information exchange, like what speed limit is at that particular segment of the roadway. The eTrans tool expects the lane level speed information, whereas the way we are set up on our computer, it uses the approach level. So that was practically the only difference. Otherwise, the thing worked flawlessly. And this was a tool that is made by eTrans, and we had very good experience with that. So that's something I just want to share, although there is no slide on that on my presentation.
Thank you. I see a question about the slides on the Connected Fleet Challenge number 1. We'll look into that, and I'll make sure to fix that issue. Anything else from the panelists? All right. So we're right on time. It's 3:29 p.m. Eastern time over here. I just wanted to take a minute and thank all of our presenters, and also our moderator today, Jeremy. I appreciate all the info that was shared. I hope everyone found it helpful. Again, all the recording of these slides, this webinar along with the slides will be shared on the NOCO website. On the behalf of National Operations Center of Excellence, thank you for joining us today, and have a great rest of your day.
Okay, thank you for setting it up.
Thank you.